Um, okay.
Okay, looks good. Go ahead.
So I had a question about how would you approach number 41?
Okay, so I'll put 9.3 down here. And so we're gonna approach number 41. Okay. All right. Now for this one, it's kind of a telescoping series. So what I can do is we can sort of write this out and then figure out what the partial sum is, and then we take the limit, and then we'll be done. So let me write out the problem first. So it's a summation n equals 1 to infinity, square root of n plus 2 minus square root of n plus 1, and then you factor this over square root of n plus 1 times the square root of n plus 2. Okay. And the first point is that we want to write this as a difference of two things. So this is going to be the sum, n equals 1 to infinity. So I'm going to divide the denominator into the numerator. So I'm going to get 1 over the square root of n plus 1 minus, and then I divide the denominator into the numerator, the second thing, and it's 1 over the square root of n plus 2. Okay.
Okay. Is it n to the 2 to infinity or n to the 1?
N equals, I guess, 2, so we better change that. It's not going to make too much difference, but that's okay. All right. Now, yeah, actually will make a difference. Sorry. All right. So let's write out let's write out what this series kind of looks like. Okay. So
Okay.
what is the first partial sum? Well, the first partial sum is when I make n equals 2. So it's 1 over the square root of 3 minus 1 over the square root of 4. You agree?
Right.
Okay. And if I take the second one, it's 1 over the square root of 3 minus 1 over the square root of 4. Okay. I'll just put parentheses around here. Plus 1 over the square root of 4. Got it?
Mhm.
Minus what's the next one? 1 over the square root of what?
Square root of 5.
5. Okay, because that's n equals 3. That's that term,
Right.
right?
Right.
Okay. So you can actually see what's going to happen is that you're basically going to cancel this one off with that one for the partial sum. Okay.
Okay, I see it.
All right.
Yeah.
Good. All right. So the partial sum here, Sn, is equal to 1 over the square root of 3. And the last term is going to be, I believe, n plus 3, right? Minus 1 over the square root of n plus 3.
Is it n plus 2 or?
I think it's n plus 3.
Oh, n plus 3. Okay.
Yeah. Is that okay?
Why is it n plus 3?
Well, look at S2, right? You take S2 and the last term is 1 over the square root of 5.
Mm-hmm.
So you have to add 3 to the subscript.
Okay. I thought it was 3 plus 2 and n is 3.
No, n is 2 here. See, this is subscript is a partial sum here.
But if we start at 2, then it would be 3, right?
Well, the point is that this is the first term. We call it A1.
Right.
This is A1 plus A2. You know, it just indexed. There's a shift in the indexing. That's all there is.
Okay.
Okay.
Yeah, that makes sense.
But ultimately, I mean, it doesn't matter if you shift it one way or the other. You're going to take the limit anyway. Okay. Great. So here's the partial sum.
Okay. And you take the limit of that, right?
Right. So then S is going to be, of course, a limit as n tends to infinity of this partial sum. I'll let you finish the problem off.
Okay.
Okay, so and I'll let you finish this. Okay,
Okay.
all right. Great.
I think that's the only question I had for 9.3.
You know, we should probably do one more on 9.3 for.
Yeah, that's what I was thinking. So
All right, so this is for the other students out there.
yeah.
All right,
Maybe 32.
okay, 32. Okay, so we'll do 32 also. All right, so you take the sum from, let's say, n equals 1 to infinity of 1 over the natural log of 3 to the n, right?
Mhm.
Now, we want to know whether these converge or diverge, right?
Yes.
Now, if I take 1 over natural log of 3 to the n,
Mhm.
that's the same as 1 over natural log of 3 to the nth power, right?
Right.
And so I can rewrite this series as a sum, right?
Mhm.
And you probably did this already, right? You just 1 over
Yeah.
ln 3 to the n, okay. And what did you notice about 1 over natural log of 3?
It's a geometric series.
Good, so good. So we can compare to just the sum from n equals 0 to infinity of this thing, which is technically the geometric series. Well, it is. So this is a geo series. Okay.
Okay.
So what can you say about this geometric series?
That it converges because it's
Okay.
less than 1.
Okay, so this converges because 1 over ln 3 is less than 1. Excellent. Okay. And
Right.
so hence the other one converges. So hence, because you're just adding one more term onto it, right?
Mhm.
N equals 1 to infinity, 1 over natural log of 3 to the n converges. Okay, good. Very nice.
Are you comparing the two two summations, the one of the geometric series and the original one?
Yeah, because the thing is, you really, how do I say this? It doesn't matter whether you start from 1 or 0. It's just a matter of convergence, right? I mean,
Right.
if I was taking the actual sum and finding out what the actual sum was, I'd have to start with n equals 0.
Right.
Yeah.
Um,
So I would say n equals 1 here, just to be careful. Okay. Good.
let's see.
Okay. So maybe we can move on to 9.4 then.
Okay.
Let's see if we have
Let's see.
any other customers here. 2 participants. Okay. Just want to see if anybody else emailed me.
Okay.
Should we use the right one here? Okay.
Just a quick question for number 7,
Is this on 9.4 or 9.3?
9.3.
Okay. Sure. Number 7.
When we take the I think I did the limit test or the integral test, sorry.
Yeah,
Would you use U substitution?
yes, that's
Okay.
correct. Okay, so I'll just write this down since you asked it.
Okay.
So for number 7, we want to do, I won't write all the details.
Mhm.
Okay, so you have n over n to the n squared plus 4. And then what you use the integral test with the integral from 1 to infinity x over x squared plus 4 dx. Okay, and then you use a U substitution for this.
Right.
Okay. Okay. I hope that's enough hint for people. Okay,
Yeah.
good. Great. Okay, are we ready to move to 9.3?
Yes.
9.4, sorry, 9.4.
Yeah, 9.4.
Okay. Excellent.
Number 13.
Okay, so let me label this. I'm gonna put a line here just
Okay.
to indicate that's a new section here. So we do 9.4. And did you say number 13? Is that right?
Yes, that's correct.
Okay. Yeah, so I was actually thinking about this this morning.
Mhm.
I have this written on my whiteboard up here.
Mhm.
I
Yeah.
actually have a whiteboard in front of me in my office
Oh, okay.
at home. And so I was thinking, do we need to make it that difficult to use they're saying use a limit comparison test, but
Yeah.
let me just show you, maybe you had some ideas too. So basically, let me write this out. So you have the summation here, n equals 1 to infinity of 5n over square root of n 4n, right?
Hmm.
That's the problem. And if I really want to write this out, I can write it out in the following way, where I take n equals 1 to infinity, 5/4 to the n over the square root of n. Right, I could bring the 5/4 up to the top. Okay.
Okay.
But notice that 1 is always bigger than 5/4 to the n, right?
Right.
So I can actually compare with the square root n equals 1 to infinity, 1 over the square root of n, and this certainly can be less than n equals 1 to infinity of 5/4 to the n over a square root of n. So in particular, 1 over the square root of n is less than or equal to 5/4 to the n over the square root of n. Right. So we have
Mhm.
this over here, and then we have this kind of thing. And what do we know about this series down below here?
It's a p-test.
P-test. Good.
P-test.
And what can you say via the p-test?
It diverges or
Diverges. Very good.
diverges.
Diverges. Okay. And so now what can we say about the original series up here?
It also diverges
Okay,
by direct comparison test.
good.
Or-
So using the direct comparison test. Now I know we didn't use the limit comparison test, but
Yeah.
on the exams, I will not say use this test or that test.
Okay.
So I don't want to handcuff you in
Right.
terms of what. So if it's easier just using direct comparison, which I think it is, then
Okay.
just use direct comparison test. Because otherwise you have to cook up something maybe kind of weird. So using direct comparison test, we know that this thing converges.
Okay.
Okay.
Um.
So diverges. Okay, so we got to do that again. Sorry.
Yeah. Diverges.
Diverges. Very good. Okay, great.
37.
All right. So 37. Okay. So I have the sum n equals 1 to infinity. 1 over 3 to the n minus 1 plus 1.
Mhm.
Okay. And now, I mean, do you think this converges or diverges?
It diverges, or
Well, I mean,
maybe converges.
forget the plus 1 on the bottom. Okay, because that's not going to make that much difference.
Mhm.
This 3n plus 1. So why don't we look at comparing it to
Well, approach
n equals
limit
1?
approaches 0.
Yeah, that's okay. But what if I told you we can just kind of forget the 1 and
Okay.
look at this, right? So this looks, now if I just rewrite this, I can actually sum it from n equals 0 to infinity of 1 over 3 to the n, right? I could just pull the thing back.
Mhm.
And this is the sum, n equals 0 to infinity, 1/3 to the n. So does this series converge or diverge?
It converges, right?
Converges, right? So converges because we know 1/3 is less than 1, and it's a geometric series.
It's a geometric series, so it start from 0.
Yeah, but again, if you start with anything, it just matters what happens with the tail of the series, right?
Okay. Yeah,
So
that's right.
if you just add a few terms at the front, it doesn't matter whether that's not going to affect the convergence or divergence. Okay.
Okay.
Okay, good. All right. So we have these two series, and we know one converges. So we just have to apply the limit comparison test. So now we're going to apply the limit comparison test. And so I want to take the limit as n goes to infinity, one over the other. So let me do it this way. So 1 over 3 to the n minus 1, okay, over 1 over 3 to the n minus 1 plus 1, okay?
Okay.
This is the limit as n tends to infinity. Now I can flip this one up on top. So, I could sort of flip 1 over something up to the top, right? And then
Mhm.
push the other thing down below.
Right.
So this is 3n minus 1 plus 1 over 3n minus 1. Okay.
Okay.
And as you can see, I can divide. So this is 1 plus 1 over 3n minus 1, right? And what's this limit going to be? So as n goes to
1.
infinity, 1. Excellent. Okay, 1. Great. So now I can use a limit comparison test because the limit is finite and bigger than 0,
Right.
less than infinity. So by limit comparison test, we know that the sum here, n equals 1 to infinity, 1 over 3 to the n minus 1 plus 1 converges. Okay,
Yeah. I got it.
good.
Um, that was my last question.
Okay.
Let's see.
So were you able to do 53?
No, I haven't gotten to that yet.
Let me give you a hint on 53. Okay.
Okay.
So this is for everyone out there. This is kind of a fun problem.
Okay.
Okay. All right. So so you need to know like 1 plus 2 plus 3 plus da 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 plus n. Okay. So this was a problem that was posed to Gauss when he was 10 years old. Gauss is a very
Mhm.
famous mathematician. So sum the numbers from like 1 to 10. And he was able to do it very quickly.
Mhm.
Sum the numbers from 1 to 100. He was still able to do it very quickly. Right?
Mhm.
So you think, well, how can a 10-year-old like actually find the sum of these numbers? Right?
Mhm.
Um, so So what Gauss kind of said was, well, look, I mean, if I take one and n, and if I sum these two numbers here, that's going to be n plus one, right? One
Mhm.
plus. But then also if I sum these numbers over here, that's also going to be n plus one too. And I just keep on going. So I just have to count how many times I sum n plus one. And then I can get an answer. So
Mhm.
there's a formula for this. N plus one, and then you sum it basically n over 2 times. And this is the formula for the sum of numbers from 1 to n.
Mhm.
Okay, so let's make sure this works. Okay, so let's say 1 plus 2 plus 3. Well, we know what the answer is, 6, right? And here n is equal to 3. Okay,
Mhm.
so here I get 4 times 3 over 2, which is actually 6, right?
Mhm.
Okay, so it works out. And then you could check up for the other ones too. Okay,
Yeah.
good. So when you write this whole thing out, it's not as hard as it looks. So if I take the sum, n equals 1 to infinity, 1 over 1 plus 2 plus n. This is the sum, n equals 1 to infinity, 1 over, and then I'm just going to put this formula in, n plus 1 times n, and then over 2. And I can just rewrite this as following. N equals 1 to infinity of 2 over n plus 1 over n. Okay. And
Okay.
now you can see that the leading term is n squared, right?
Mhm.
And then, it's going to, you can use p-test and limit convergence test, comparison test to actually show this thing converges. So
Okay.
I'll let you finish the problem. Okay.
Okay. Where do you get the equation n plus one n over two?
It's because if you look at summing like 1 and n over here,
Mhm.
the sum at the ends is n plus 1. And then you move in, the sum is n plus 1. The sum is n plus 1. How many times do you do it? N over 2 times.
Oh, okay.
See, so
Okay, that
instead of
makes sense.
summing linearly, you sum them up. This is, a 10-year-old
You're right.
was able to figure this. This is pretty clever, I think, for a
Yeah.
10-year-old. Well, of course, he was a great mathematician too, but
Yeah.
there's a story behind this anyway.
Mhm. Yeah, that makes sense. I get it.
So, you can like, for anyone out there, who sees this, you can like impress your friends by, knowing how to do this in a
All
very
right.
fast way. So, okay.
Okay.
So I'll say finish the problem. So I'll say finish here. Still a little work to do, but we can finish it from there.
Hmm.
Okay. Are there other questions?
For number 18,
Okay.
could you use the direct comparison test for 1 over n and say
Yes.
it diverges by the p-test and then
Yes.
compare that to the other
Yeah.
one?
Yeah. I would use like limit comparison. Just take the limit. Just do 3 over n or 1 over n. Let me
Okay.
write this down as a note. So what's this, 18?
Yes.
So I'll just say you can use limit comparison test with summation. Well, you can either use 1 over n. That's
Mm.
good enough. Okay.
Could you use direct comparison test with that as well?
Let's see. So if I put in something which is less, I get something which is greater.
And
Not so.
1 over n is greater than 3 over n plus.
Well, the problem is
square root of
this. I think the problem is this. The n is going to be less than or equal to n plus square root of n, right?
Mm.
Okay. So when I take the
Yeah.
reciprocal, it's the other way around. You know, you're kind of out of
Yeah.
luck, right?
Uh,
So it's
okay.
probably better to use limit comparison test.
Okay.
So in other words, like 1 over n plus the square root of n is less than or equal to 1 over square root of n. So it's not, so this is not good. Let me just write it out.
Right.
So it's not, the direct comparison is not so great to use here.
Yeah.
Okay.
Yeah. Okay. See. Any questions? For number 8,
Mhm.
could you? I use the direct comparison test for this one. Could you just compare it to 1 over n to the 1/2?
You can. There are probably various ways to use direct comparison, but yeah, you can use direct comparison test for this one.
Okay.
Yeah.
Then I think that's it for me.
Okay, great. Yeah, so it was good. So I'm just waiting. I guess this will, any other customers? No. Okay.
No.
So what I'll do is we will stop. Let me stop the recording.
Okay.
Okay.